Hello. In this video, we're going to be learning about comparing fractions. And to do that, we're going to be looking for common numerators as well as common denominators. We're also going to be learning about how to make common numerators and common denominators by finding equivalent fractions. But all of that is going to be used for the idea of comparing fractions to see which are greater than others, which are less than others, and which might even be equivalent to others. Let's dive in and get started. So, to review, one of the concepts that we worked on recently has to do with comparing fractions to 1/2. So, for example, we can look at the fractions 2/6 and 5/8. And as a quick review, we learned how to say, okay, what's a fraction that's equivalent to 1/2 that has a denominator of 6? And we know that that's going to be the fraction 3/6. Since 2/6 is less than 3/6, we know that 2/6 is less than half. On the other hand, when we work with 5/8, we can ask ourselves, okay, what's a fraction equivalent to 1/2 that has a denominator of 8? And we know that that's going to be 4/8. 5/8 is greater than 4/8. So we know that 5/8 is greater than half. So since 5/8 is greater than 1/2, and since 2/6 is less than 1/2, we know that 5/8 has to be greater. 2/6 is less than 5/8. We learned that that strategy isn't always going to help you. For example, a fraction that's equivalent to 1/2 with a denominator of 10, well, that's going to be 5/10. 7/10 is greater than that. So we know 7/10 is greater than half. And 9/12, a fraction equivalent to 1/2 with a denominator of 12, well, that's going to be 6/12. 9/12 is greater than 6/12. So we know that 9/12 also is greater than half. So, gosh, our strategy stops working for us. Now, somebody might think that that means that 7/10 and 9/12 are equal because they're both greater than 1/2, but that's not true. We can't assume that these are equal just because they both happen to be greater than 1/2. So, in today's lesson, we're going to learn how we can work with fractions like this, how we can figure out which one is greater than the other. So to start things off, we're going to look at comparing fractions with common denominators. So to begin, let's take a look right now at the fractions 8/12 and 11/12. Now, first of all, the denominator, we can often think of a denominator as almost like a unit. So just as this is 8/12 and 11/12, we could think of this as 8 apples and 11 apples. And we know that 8 apples is less than 11 apples. We know that 8 snowballs is less than 11 snowballs. We know that 8/12 is less than 11/12. So we can tell just from the language that 8/12 is less than 11/12. But I can prove that to you. Let's take a look at this picture right over here, this diagram. Sure enough, I've divided my whole into 12 parts and I've shaded in 8 of them. And so this diagram is showing me 8/12. This diagram is showing me 11/12. And you can clearly see 11/12 is larger than 8/12. And it's also just something you think about. If I have a pizza that's cut up into 12 pieces, 11 of those pieces is more than 8 pieces. Anytime you have the same number of parts total, 8 is going to be less than 11. If it's 8/10, that's still going to be less than 11/10 or 11, we're not really working with improper fractions yet. But the idea that 8/12 is clearly less than 11/12. And we can do this with lots of other kinds of fractions when you have a common denominator. Let's take a look at some of them. 3/5 versus 4/5. Well, just as I could say 3 tomatoes is less than 4 tomatoes, 3 race cars is less than 4 race cars, I can say 3/5 is less than 4/5. And again, if I divide a candy bar up into 5 parts, 3 of those parts is less than 4 of those 5 parts. We can do it with thirds. I can say 2/3 versus 1/3. Well, 2 houses is more than 1 house. 2 computers is more than 1 computer. 2/3 then is more than 1/3. And so once again, we're going to say that 2/3 is greater than 1/3. Let's try it with eighths. I could compare 6/8 to 2/8. I could say 6 markers is more than 2 markers. 6 document cameras is more than 2 document cameras. 6/8 is more than 2/8. So 6/8 is greater than 2/8. Let's do one more. Let's do ninths. I can compare 3/9 along with 7/9. Pause this video and use your strategies to figure out which is greater and which is smaller. Is 3/9 greater than 7/9, or is 3/9 less than 7/9? So hopefully you thought about it. You recognize that 3 is less than 7. So just as 3 pieces of paper is less than 7 pieces of paper, 3 books is less than 7 books, 3/9 is less than 7/9. And the good rule of thumb when you're comparing fractions with common denominators is that the bigger the numerator, the larger the fraction is. So here, because they have common denominators, I have a bigger numerator here with 11/12. So this is the larger fraction. With my fifths, common denominator, 4/5 is my bigger numerator, so that's the larger fraction. Common denominator here, here's my larger numerator, so 2/3 is my larger fraction. You get the idea. Now let's work on comparing fractions using common numerators. Before we were looking at what happens when you have common denominators, when the whole, the number on the bottom of the fraction is the same. But now we're going to look at what happens when the numerator, the number on the top of a fraction, is the same. So let's compare 1/2 to 1/8. Well, I can draw that out and I can see that 1/2 I've shaded in half of my shape versus 1/8. When I've broken my whole into 8 small parts, I've only shaded in one of those 8 parts. So in this instance, 1/2 is greater than 1/8. Let's take a look at another example. This time I have 2/6 and 2/10. So again, I have common numerators. They're both 2 parts. But when I have 2/6, that means that I'm taking my whole and I'm dividing it into 6 parts, and I've shaded in 2 of them. But with 2/10, I've still shaded in 2 parts, but this time it's 2 out of a total of 10 separate parts. And right now you can see I've shaded in much more with 2/6 than I have 2/10 because each of those 2 parts is larger than when I divide the whole up into 10 parts. So 2/6 is greater than 2/10. Let's take a look at another example. 4/5 and 4/8. Well, in this example, with 4/5, I've shaded in almost my entire whole. I divided my whole into 1, 2, 3, 4, 5 parts. I shaded in 4 of them. But when I had 4/8, I divided my whole into 8 parts. I shaded in 4. That's the same as half. I've shaded in half of my whole. A common mistake when using common numerators is that kids sometimes think that they're equivalent because they both have one part shaded, or they both have 2 parts shaded, or they both have 4 parts shaded. But that's not the case. It's about how big each of those parts are. So if we look at this last example again, you can see pretty plainly that 4/5 is much more than 4/8. 4/5 is greater than 4/8. And that's because each of those parts, each of those fifths here is much larger than those smaller eighths. So 4/5 is more than 4/8, even though they're both showing 4 parts. Let's do a couple more examples. Let's say I had 1/2 and I wanted to compare that to 1/20. Well, part of it is just to imagine in your head, to visualize what that would look like. 1/2, I know that's half of my whole. 1/20, wow, that's really small though, because if I imagine my whole broken up into 20 parts, I've only shaded in one of those 20 parts. That's much, much smaller. So 1/2 is greater than 1/20. Let's take a look at another example. Let's take a look at 3/4. So now I've got 3/4 right here, and I'm going to compare my 3/4 to 3/9. And I could even use my strategy of comparing things to 1/2, but I can visualize in my head 3/4 is a lot. If I imagine my whole divided into 4 parts, 3 of those, that's almost my whole thing. Whereas 3/9, that's a smaller amount. Each of those ninths is going to be much smaller. And so 3 of them is going to be a lesser amount of my fraction. So 3/4 is going to be greater than 3/9. Let's take a look at another example here. Let's compare 5/20 to 5/12. And in this example, 5 out of 20 whole parts here and parts in the whole, that's not a whole lot. Versus 5/12, my whole is divided into fewer parts, 12 parts versus 20 parts. So those 5 parts are going to be larger. And so I know that 5/20 is going to be less than 5/12. And let's do one last example. Let's compare 10/10, and we're going to compare that to 10/100. This is perhaps the best example of where you can just really think about what that amount looks like. If I have a whole and I divide it into 10 parts here, and I'm looking at 10 parts, that's equivalent to one whole. 10/10, that's a whole. Versus if I have a whole that I divide into 100 parts, and I only have 10, well, gosh, there's still a lot left over. 20, 30, 40, 50, 60, 70, 80, 90, 100. I'm only talking about 10 of those out of 100 total. That's a very small amount. So 10/10, that's one whole, is much, much larger than 10/100. You may have noticed a pattern. In our previous example, when we were talking about common denominators, we said that when you have common denominators, the larger the numerator, the bigger the fraction. So the larger numerator here had the bigger fraction, 11/12 versus 8/12, or 6/8 versus 2/8. The larger 7/9 compared to 3/9. But that same rule doesn't apply for comparing fractions when you use common numerators. Because now, first of all, the numerators are all the same, but with the denominators, the larger the denominator, the smaller the fraction. Think about it. 1/8, larger denominator than 1/2, is a smaller fraction because each of those parts is divided up to a smaller size. 2/10 versus 2/6. Well, gosh, 2/10, I have 10 pieces. So each of those pieces, those 2 pieces, are going to be much smaller. 6 is going to be a larger portion. Again, the bigger the denominator, the smaller the fraction is. Let's do a little practice as a group. And I even reminded you of some of the rules here. So we're going to go through each one, and I'm going to read it to you, and I'm going to have you pause and try it yourself. But let's take a look at the directions, the reminders, the rules here. When you have common denominators, fractions with larger numerators are greater than fractions with smaller numerators. So let's look at this first one, 3/8 versus 5/8. Please pause this video now and you can figure out which is greater, 3/8 or 5/8. Well, we can use our strategy. Fractions with larger numerators are greater than fractions with smaller numerators. 5/8 is clearly going to be greater than 3/8. So I'm going to say 3/8 is less than 5/8. Let's go on to the next one. We're going to compare 4/5 and 3/5. Please figure out which one is greater than the other. Hopefully you said 4/5 is greater than 3/5. Let's do this last one. 8/10 compared to 6/10. So 8/10 is certainly 8 is larger than 6. So hopefully you said that 8/10 is greater than 6/10. Now let's shift what we're doing and let's review what we've learned about common numerators. When you have common numerators, fractions with smaller denominators are greater than fractions with larger denominators. This tends to be the trickier part for kids. This is where they get a little bit mixed up because it's almost backwards from what you'd expect. Smaller denominators give you larger fractions, and larger denominators give you smaller fractions. I know that this is confusing, but the good part is when we are comparing fractions, most of the time we're going to work with common denominators. We don't do as much with common numerators, but let's practice it because it is a skill that you're going to want to have, and I'm going to show you why in just a few minutes. 4/6 compared to 4/12. You have to decide, is 4/6 greater than 4/12 or is it less than 4/12? 4/6 is greater than 4/12. Let's go on to the next example. We have 7/20 and we have 7/11. Hopefully you said 7/20 is less than 7/11 because even though they're both 7 parts, the 11 parts are going to be much bigger than those 20 small parts. So 7 of those smaller parts is less than 7 of the 11 bigger parts. Let's go on. We have 8/12. 8/12 compared to 8/20. Pause the video and you figure it out. All right, so we've got 8/12 compared to 8/20. And hopefully you recognize that 8/12, the 8 is, those 8 larger pieces are going to be greater than the 20 smaller pieces. Now let's try some mixed items. So I'm not going to tell you which strategy to use, but I am going to zoom out a little bit so that you can hopefully see. Can't quite see them all here. Thanks for bearing with me. We are comparing 6/8 to 6/11. Pause the video and figure out which is greater. So we've got common numerators here. 6/8 is greater than 6/11. Let's try this next one, 5/8 and 7/8. Ooh, I spot common denominators here. 7/8 is greater than 5/8, so we're going to write 5/8 is less than 7/8. Let's do the next one. Common denominators, once again, 4/9 and 8/9. I'm going to say that 4/9 is less than 8/9. And a good strategy you can also use, although we're not really focusing on it right now, is again looking at how close together the numerator and the denominator are. There are 9 parts here. And I'm looking at 8 of those. 8 of the 9 parts, that's almost one whole. Versus 4 of the 9 parts, well, there's a whole lot that we're not focusing on. That's closer to 1/2. 7/8, that's 7 out of 8 parts. That's almost one whole. Compared to 5 out of 8 parts, that's much less. 6/11, there's a lot between 6 and the 11 total versus 6 when you have only 8 total, that's closer to being 1 whole. That could be another strategy for you to use. So let's look at what happens when you don't have common denominators. And let's look at some strategies that you can use to figure that part out. I have 3/8 and 2/4. My goodness, I can't compare those. They don't have common denominators yet. But don't worry, you've learned when we've worked on equivalent fractions, you've learned how you can turn fractions into other ways of expressing them. And in this case, I can take my 2/4 and I can express that in terms of eighths. So let's think, what can I do? What can I multiply 4 by to turn it into something out of 8? I can multiply that by 2. And what you hopefully remember is my favorite, it's not really a rhyme, but my favorite saying when it comes to fractions, what you do to the bottom, you have to do to the top. And what you do to the top, you have to do to the bottom. So since we multiplied the denominator by 2, we're going to multiply our numerator by 2. 2 times 2 equals 4. So really, although 3/8, comparing 3/8 to 2/4, that might be a little hard. 2/4 is equivalent to 4/8. And so I can say that 4/8 is greater than 3/8, or 3/8 is less than 2/4 or 4/8. Let's take a look at this next example here. Let's take a look at 2/3 compared to 5/12. Again, I don't have common denominators yet, but there's got to be a way that I can use multiplication and equivalent fractions in order to turn these into common denominators. I can, and this time I'm going to do it with my 2/3. I can turn that into an equivalent fraction that's out of 12. 3 times what is going to give me 12? Well, I know that 3 times 2 is going to give me 6. That's not going to get me there. 3 times 3 is 9. That won't get me there. But 3 times 4. 3 times 4 equals 12. What I do to the bottom, I've got to do to the top. 2 times 4 equals 8. So I've got 8/12 compared to 5/12. Well, clearly 8/12 is larger. So this tells me that 2/3, since these two are equivalent, 2/3 is greater than 5/12. So let's keep working on this though, because I've got here 5/9 and 4/6. And gosh, you know what? I'm taking a look right here at 5/9 and 4/6. I can multiply the 6 times anything to get 9. And I can multiply the 9 times anything to get 6. So, boy, this is where I get a little bit confused. What am I going to do in a situation like this? How do I make common denominators? Well, let's think about what I could multiply both of these by in order to get a common denominator. For example, 5/9. I could think, okay, let's see, what are some multiples of 9? I could do 9 times 2 is 18, but 6, but wait a minute, I can do 6 times 3 equals 18. Let's try this out. So if I do 5/9, I can turn 9 into 18 by doing times 2. What I do to the bottom, got to do to the top. 5 times 2 equals 10. I have 10/18. Now let's see what we can do with 4/6. 4/6. Can I turn 4/6 into something equivalent out of 18? Well, I know that 6 times 3 equals 18. So this should work. What I do to the bottom, I've got to do to the top. 4 times 3 equals 12. So while before 5/9 compared to 4/6, that was pretty tricky. 10/18 compared to 12/18, I can work with that. I can handle that. And so I know that 12/18 is larger, 10/18 is less. So I'm going to say 5/9 is less than 4/6. Let's try this next one. I've got 3/7 and 2/6. Before I was able to find a common multiple for 9 and 6 that was easy to work with. I put them both out of 18, but 7 times 2 is 14, and there's nothing I can multiply 6 by to get to that. 7 times 3 is 21. I can multiply 6 times anything to get 21. 7 times 4 equals 28. 6 times, no, that's not going to work. 7 times 5 is 35. Certainly 6 times anything. 7 times 6 equals 42. And in fact, what we can do is multiply by one another. So I can multiply this fraction by 6, or I should say this numerator and this denominator by 6. And I can multiply this numerator and denominator by 7. That's going to get me an equivalent fraction. Let's try this together here. 3 sevenths. So if I write this down here, I have 3 sevenths, and I'm going to turn that into something that's, let's see. So I'm going to multiply times 6, because that's what I have right here. 7 times 6 equals 42. That is a big, big denominator, but don't get afraid. Don't worry, I've got you covered here. What we do to the bottom, we have to do to the top. 3 times 6 equals, last time I checked, 3 times 6 equaled 18. So I've got 18/42. That's a messy fraction. It's not one we normally would want to work with because it's just large numbers, but it's actually going to help us out in this situation. Let's look at 2/6 now. I had 2/6, and just as I multiplied 3/7 by my denominator over here, times 6, I'm going to take 2/6 and I'm going to multiply it by my denominator over here of 7. 6 times 7, well, look at that. That's 42. That's why we do it, because 7 times 6 equals 42, and 6 times 7 equals 42. So that's how we can get our common denominators. So since I multiplied 6 times 7 on the bottom, on the top, because what you do to the bottom, you've got to do to the top, 2 times 7 equals 14. And again, 14/42, it's a messy fraction. It's not easy to work with, but it is easy for us to compare the two. It's easy for us to say, well, as messy as these are, 18/42 is clearly greater than 14/42. So since 18/42 is greater than 14/42, I know that 3/7, which is equivalent, has to be greater than 2/6, which is equivalent. And that could be a really great strategy. By the way, I could have used that same strategy of multiplying by the other's denominator for this one too. If I wasn't realizing that a common multiple was 18 and that I could have solved it this way, another option, I'm going now back to my 5/9 and 4/6. Another option would have been to say, okay, 5/9, I'm going to multiply it, and this time I'm going to multiply it by my other denominator of 6. 9 times 6 is 54. So 5 times 6 equals 30. And here I can take my 4/6. 6, this time we're going to multiply by the first denominator of 9. 6 times 9, it's still going to be 54. And so if I multiply my numerator again by 9, 4 times 9, 36. And so this is still going to work because 30/54 is less than 36/54. And just as we found before, that means that 5/9 is going to be less than 4/6. I don't know about you, but I find it a lot easier to work with smaller figures like 10/18 compared to 12/18. But if it's easier and you want to just multiply by the other's denominator, that's fine. In this case, we just get 30/54 and 36/54. Now, here's where you're going to do some of the practicing yourself. So same as we've done before here, I'm going to read it to you and I'm going to have you work it out on some scrap paper and see if you get the same answer that I get. Let's start right over here. 4/7 compared to 11/21. So let's figure out what we can do. Pause this and you try and figure it out. You're going to have to do some multiplication to get common denominators. Pause the video and give it a try. All right, so for 4/7, hopefully you realize that I can turn something out of 7 into something out of 21. I can say that 4/7, I can multiply 7 times 3, and I'm going to get 21. What I do to the bottom, I have to do to the top. 4 times 3 equals 12. So really, when I say 4/7, that's the same as saying 12/21. And 12/21 is just a hair bigger than 11/21. So that tells us that 4/7 is just ever so slightly greater than 11/21. Now, let's try 7/12 and 5/8. Think about what strategy you can do to solve this. Give it a try. So there are a bunch of different ways in which we could have solved comparing 7/12 to 5/8. One option would be to say, all right, we're going to multiply those denominators by one another. 12 times 8 here. So if I take my 7/12, 7 over 12, that's the same as, gosh, if I multiply 12 times 8, that's going to give me 96. And 7 times 8, what we do to the bottom, we've got to do to the top. And if on both of them we're multiplying by 8, 7 times 8, that's 56. Let's try 5/8 now. 5/8, and I'm going to multiply that this time by 12, by the other denominator. So 8 times 12, that's still going to give me 96. So I need now 5 times 12, and that's going to give me 60. So I'm comparing 56 96. Really messy fraction, but we can still compare 56 96 to 60 96. Clearly, 60 96 is bigger than 56 96. It's a lot of sixes. So I'm going to say 56 96 is less than 60 96. So 7/12 is less than 5/8. You may not have done it that way, though. You may have instead thought of, oh, a common multiple of 12 and 8 is the denominator of 24. You may have recognized, and I don't have a ton of room here, so just bear with me, that 7/12 is equivalent, I can multiply my denominator by 2 and get 24. If I multiply my numerator by 2, I get 14/24. And gosh, with 8, 5/8, I can multiply 8 by what? Gosh, I know that 8 times 3 is 24. And so if 8 times 3 is 24, 5 times 3 is 15. And again, 15/24 slightly greater than 14/24. 14/24 is less than 15/24. So 7/12 is less than 5/8. Let's go on to the next problem here. We're going to compare 1/3 to 3/5. All right. So hopefully you went through it. 1/3 to 3/5. Again, there's nothing I can multiply 3 times to get fifths, nor is there anything I can multiply or divide, for that matter, 5 by to turn it into 3. So in this instance, we're going to have to just multiply by one another here. So 1/3, if I turn that into something here, times 5, well, 3 times 5, let me make that a little neater here. 3 times 5, that's 15. What I do to the bottom, I've got to do to the top. 1 times 5 equals 5. So now 1/3 is equivalent to 5/15. Let's try 3/5. 3/5, on the other hand, I'm going to look for an equivalent fraction. I'm going to find that by multiplying by the other denominator, 3. 5 times 3, 15. Here are common denominators, 15 and 15. And what I do to the bottom, times 3, I've got to do the top. times 3. 3 times 3 equals 9. So really, I'm comparing 5/15 to 9/15. Clearly, 5/15 is less than 9/15, so 1/3 is less than 3/5. Let's take a look at this last one, 7/8 to 12/16. Let's think about how this one can work. My goodness, here, I could use that same strategy of multiplying by the other's denominator, but hold on a minute here. If I'm going to use that same strategy of multiplying by the other's denominator, we've got, oh my goodness, 8 times 16 here. I'm going to end up expressing these in a fraction out of 128. This is getting a little ridiculous. There's no need for us to do anything that crazy because, again, I can look for my common denominators. So I could easily turn 7/8 into something out of 16. I could say 7/8, and I can multiply that denominator times 2, and that gets me 16. If I'm doing times 2 for my denominator, what do I do to the bottom? I've got to do to the top. 7 times 2 is 14. 14/16 compared to 12/16. And that tells me 14/16 is slightly larger than 12/16. So 7/8 has to be larger than 12/16. But there's something else that I could do. Don't forget about the wonderful world of division. You can use division to solve this problem as well. I could take, for example, 12/16, and I could actually simplify that a little bit. I could take my 12/16, and I could, instead of multiplying, I could use division. I could do 16 divided by 2, that's 8. What I do to the bottom, I've got to do to the top. 12 divided by 2 is 6. So I could also look at it and compare 6/8 to 7/8. And of course, 6/8 is slightly less than 7/8. 7/8 is greater than 6/8. So I could really use either of these strategies to solve this. And I'm curious which one you used. And finally, let's do just a little quick practice with making common numerators. Now, by the way, you might be looking at this and thinking, well, gee, we can make common denominators. And yeah, 7 times 9, 63. I can express these both into fractions out of 60/3. And you'd be correct that if I turn this into 3/7, if I did that something out of 63 and 6/9, I turn that into something out of 63, it would work. You'd absolutely be able to do it. That could get the job done, but you're working too hard right there because I have 3 and I have 6. Let's just make them both common numerators. Let's turn 3/7 into, let's see, this time I want to turn it into 6. I know that 3 times 2 is going to give me 6. What I do to the top, I've got to do to the bottom. 7 times 2 is 14. So here's what I now know. I'm really comparing 6/14 to 6/9. And boy, when I think about that, 6/14, those 14ths are going to be pretty small. So I'm thinking of that same strategy. 6/9, okay, each of those ninths is going to be a little bit bigger. So if I've got common numerators, 6 pieces each, the 9 parts are going to be larger. So I know that 6/14 is less than 6/9. So 3/7 has to be less than 6/9. Now, this next problem is kind of interesting because I could actually use common numerators or I could use common denominators. But again, here, 3 times, I'm not going to be able to really do anything easy with 16ths here. 3 times 16, that's going to give me a huge number that I don't want to deal with at all. So here, I really wouldn't want to do common denominators. This is the situation, again, we're working with common numerators is going to really help us out. So this 2/3 here, I'm going to find an equivalent fraction. I've got 2/3, but I want to express that out of 6. So let's take a look right here. 2/3, if I'm trying to turn that into 6, 2 times what equals 6? I know that's 2 times 3. What I do to the top, I've got to do to my bottom. So I've got 3 times 3. Well, that's going to equal 9. So now I'm really comparing 6/9 to 6/16. Imagine in your head, visualize this, my whole divided into 9 and my whole divided into 16. Those 9 pieces, each one is going to be bigger than the 16 pieces. And so if I have 6/9, that's clearly going to be more than 6/16. So 6/9 is greater than 6/16. So 2/3 has to be greater than 6/16. Now I'm going to have you give it a try right now. We're going to start off by comparing 1/9 and 5/8. Pause this video and figure out what is greater and what is less. So again, I could do common denominators if I wanted, 9 times 8. It would work here, but let's give this a try here. I could do, oh gosh, if I take my 1/9, my 1/9 right here, I can turn that into 5 something. 1 times 5 is going to give me 5. What I do to the top, I've got to do to the bottom. 9 times 5, that's 45. That's that same example where visualizing it helps. Imagine my whole divided into 8 pieces versus my whole divided into 45 pieces. 5/8 is way bigger than 5/45. Each of those 45ths are going to be a teeny tiny sliver. Imagine a pizza cut into 8 slices. Those are going to be some pretty generous slices. Versus a pizza cut into 45 slices. They're going to be minuscule. So eating 5 of those 8 slices is going to be way more than eating 5 of the 45 slices. Now let's try the next one. 9/12 compared to 3/7. Pause this video and give that one a try. All right, so this time we can turn 3 into 9. So I've got 3/7, and I'm going to use my multiplication to say 3 times 3 equals 9. What I do to the top, I've got to do to the bottom. So 7 times 3 equals 21. So I've got, all right, here, 9/12 versus 9/21. And we can use that same strategy here. I like to visualize those pizzas. That's something so many of us are familiar with. If I have a pizza cut into 12 slices, okay, they're not going to be super big, but those 12 slices are going to be way bigger than a pizza cut into 21 slices. So 9/12 is greater than 9/21. So 9/12 is greater than 3/7. Final practice. You choose your strategy. I'm not going to go through these in a whole lot of detail right now because I think you've got the idea here. But let's go through them one at a time here. And I'll go over them if they get a little tricky. We have 7/20 and 1/4. You choose your strategy of how you want to compare. Pause this video and solve this first one. So this is an interesting one because I could have turned this into multiplying by 7. I could have turned this into, what would this be? 7/28 and compared 7/28 to 7/20. Or I could have turned this into the common denominator of 20 and done 4 times 5 equals 20, 1 times 5 equals 5. I could have turned this into 5/20. So whether you did 7/28 or 5/20, either way, it's going to tell you that 7/20 is greater than 1/4. Let's go into this next one. Same situation here. I easily could have made common denominators with 3 and 5. I could have turned them into 15ths to compare them. Or I could have done common numerators, and I could have turned 2/3 into 4/6. No matter which of those strategies you tried, whether it's common numerators or common denominators, hopefully you found that 2/3 is less than 4/5. go on to our next one here. So in this example, you could have done either one, I suppose, because 9 and 8, you're going to have to just multiply them by one another. And 6 and 7, again, you'd have to multiply them by one another. So this is actually a bit of a tricky problem right here, but we can still figure out that 7/8 is greater than 6/9, or 6/9 is less than 7/8. Let's take a look at our last problem of the video here. You've made it to the end, folks. Yep, no more papers. I wanted to double check. 3/4 compared to 4/6. Same situation. You're going to have to change both of these in order to get common numerators or common denominators. So if I'm doing common numerators, maybe you change them both so that they're expressing the common numerator of 12, 4 times 3, and 3 times 4. That would have worked. And for the denominators, you could have multiplied the 4/6, multiply the numerator and the denominator by 4, and the 3/4 by numerator and denominator by 6. You could have expressed it out of 24ths, but you actually didn't even need to. You could have also converted it to be out of 12ths. You could have said 4/6, well, multiply the denominator by 2, make it out of 12ths. And that means the numerator you've got to multiply by 2 to make it 8/12ths. And with 3/4, 4 times 3 equals 12. So 3 times 3 equals 9. And any of these strategies, whether you did common numerators, common denominators using 12ths, common denominators using 24ths, either way, you should have figured out that this fraction, the 3/4, is greater than 4/6. In this video, we've been working on comparing fractions using common numerators and common denominators. And just to wrap it up, most of the time, we're going to be using common denominators. That's the most common, no pun intended, the most common way to compare two fractions. But it's good to have an understanding of how to work with common numerators for those situations where it really is just easier to work with common numerators. I hope this was a helpful guide for you. Have a great day.